Good morning, everybody. Welcome to our robotics webinar for the month of October. Today, I'm going to go through just some of the basics and a bit of an introduction to the MELFA robots that are offered by Mitsubishi Electric. My name's James Adams, by the way. We'll have a bit of a chat with regards to what our offerings are on the robotics side. We'll look at a couple of applications and we'll go through a couple of technical details as well. There's quite a lot of information on my slides today, but we'll just go through it nice and slowly. There's not too much of an information overload, just to sort of give you a broader picture of exactly what our robots do. So robots have been around for quite a while, since probably the early 80s. And there is a massive push in the automation industry to automate and simplify applications as we go further down the line. The latest and greatest where we're looking at is by using AI and machine learning based technologies to create a more advanced and a more sophisticated robot. Our robots are, you will find them in all sorts of industries, from food and beverage to packaging, all the way through to agriculture and manufacturing as well. So we have an application solution for any application essentially that you would require. And we'll touch on a couple of bits and pieces as we go along. So just a bit of an introduction to MELFA robots. The first robot that Mitsubishi created was in 1980. It was a 3-axis robot, a very simple type of design. There might even be one or two of them still working today. They're extremely robust, extremely capable. And in 1982, we had the first articulated 5-axis robot made its appearance to the world. And then further on, the first SCARA robot, which is more for your high-speed pick-and-place 4-axis robot, high accuracy, came around in 1983. Since then, there have been an absolute massive array of upgrades and new robots that come through, all the way through to where we are today with our latest RV4 robots and our RH robots as well for our SCARA. So I'll explain a little bit more about that. So the types of robots we work with is SCARA robots. As I said, your high-speed pick-and-place applications. We have fully articulated robots, which would be 6-axis for having a bit more sort of movement and control for more applications that work in all the Cartesian plane. We also have delta robots, which kind of look like spiders, or deltoid robots. And then we start moving into the safety robots, where we have more sort of assistive and then collaborative type robots. So we'll go through some of those as well. Our robots, we can go all the way through on the large scale. We can go all the way through to about 70 kgs of pickup load. And generally the reaches would change between 1 meter to 2 meters, depending on the type of robot. And the accuracy is very, very, very good. A repeatability rating of 0.02 millimeters pretty much across the range, which is highly accurate. Our robots have our MRJ4 servo motor and encoder systems inside of them. So it's a technology that Mitsubishi knows very well, and it is a very, very reliable and robust solution. Some of our robots can be found in clean room and food environments. We have specialized types of standards that we have to adhere to, with positive pressure inside the robot as well, and also negative pressure if required, to utilize these robots in a high specification clean room and pharmaceutical environments as well. So just a bit more of an intro. I've just put a lot of pictures and things in this slideshow, but we'll have a look through it. We've got a SCARA robot on the left-hand side. This is the first robot we look there. Then we have safety robots or articulated robots with a skin, and then we have our collaborative robot, which we will discuss further down the line. So this is an example of some of the robot offerings we do have today, and we'll discuss exactly what we use them for. So our standard robots, as I said, 1 to 70 kilograms, and we can have a reach of about 2 meters, depending on what the requirements are. Our SCARA robots can be mounted on the ceiling as well as the floor, sorry. and they are very, very accurate and very high speed. Our articulated robots are also cannot be mounted in the ceiling, but they are quite compact and quite small, and going all the way through to the really, really big ones. And then, of course, our parallel robots, which are 4D deltas, etc., and they could be set up to work together, utilizing technology on the IQR PLCs that we will touch on shortly. So cooperative robots, basically a robot with basically like what we call a safe skin attached to them and a safety module, so that they can actually work with humans in a caged environment that will slow down and comply to certain standards. And our fully collaborative robot, which does not have to be caged if it runs at the speed that it's supposed to. We'll touch on that as well. So just a couple of our types of SCARA robots. These are quite popular. We've got a couple of applications that we're looking at with regards to these, mainly for pick and place. One of the solutions we're going to look at a bit later on is actually a gluing solution utilizing one of these robots. So the payloads start at 3 kgs, and we can go all the way to 20 kilograms with a reach of about a meter. They have built-in I/O and ports throughout the robot, where we could have an Ethernet cable to use any sort of I/O. So if you've got any electric sort of gripper or head unit that needs to be manipulated, we can do it electrically or pneumatically. The pipes are already laid out through into the robot itself, so it's very, very easy to get pneumatic grippers or anything operated pneumatic or electronically. Just a quick little chat about the model designation. All our robots have a model designation. Obviously, RH is the horizontal robot, and we also have different types. This is mainly for the SCARA robot. We have the series, and then from there we also have a bunch of different codes for is it H1 grease, so food grade environment? Do we have oil mist specification? So is it in a very dirty environment that might cause some problems? And clean room specification, ISO classes as well. We also include the Z-axis and in the part number, as well as the radius. So it does chain around, and the payload rating as well. So it's a bit of a mouthful to start with, but they all do mean something. All right, our vertical robots are the RV type robots, and they're 6-axis. What they do is they can carry payloads all the way up through to about 65 kg, 70 kgs, and have a reach of maximum about 2,000 millimeters or so. These robots are great. They can operate at a meter per second very efficiently, and they have their own controller as well, which we'll have a chat about now. So we get two different types. So the robot essentially is the robot by itself with its cables, and it connects to the robot controller. This is an example of the robot controllers. We have the D-type, so fully standalone. Our robots don't have to have any PLC integration, HMI, or anything else. They can basically operate on their own by programming the controller directly using a teaching pendant or using the RT toolbox software. So there's two scenarios. So we have a standalone application, or we could have the IQR application, where when you're doing things like collision avoidance, which we'll touch on just now, you will have to have a robot CPU going through into the IQR, and you can do all your control through from there as well. We use SSEnet for the communication between the controller and the IQR PLC, so it's extremely fast. And nothing stops us from communicating to other protocols like DeviceNet or any other sort of protocols that are not proprietary to Mitsubishi. So the only differences between these controllers, really, you can actually hook up a FX5 PLC straight in through the standalone controller and do control. It's pretty cool. We've got an application where we're doing that currently. But the only thing you would need to do is, if you really want to do collision avoidance or cooperative control, you would have to go with the robot CPU, which is the Type R controller. Essentially the same, but it comes with the robot CPU. Otherwise, all the functionality is built into the standard controller as well, which is quite nice. Okay, we have a couple of add-ons that we add as cards into our controllers for our robots, and there's two I want to touch on today. There's the MELFA Safe Plus pack, where it's an extra card and an extra safety module that we attach to the robot, which then gives us a sort of a higher level of safety. So we call this level 2. The MELFA Safe Plus pack gives us the level 2. So we have additional sensors that get hooked up for SLS, SLP, STO, STR, and that creates a safer environment for a human interaction. So when a human gets close to the robot, whether it's in the cage or opens the door of the cage, the robot will slow right down to a certain speed. So an SLS2, for instance, is 250 millimeters a second. Or if the human gets any closer, it will actually stop. So it creates an extra layer of safety with more IO and digital safety inputs and outputs with it as well. All right, so Safe Plus is an add-on kit that's highly recommended. To go further on the safety side, we will then incorporate what we call a safe skin, which will take us to the level 3 rating for safety. This is basically like a touch cover that sits on top of the robot, so it doesn't restrict its axes in any way. And if you touch it, it will stop the robot only when you touch it. So it makes it exceptionally safe. The last level that we have is level 4, which is our collaborative robot, essentially. This complies to all collaborative robot specifications and can actually be used with a human in close proximity to it. We'll touch on a little bit about that later on. Our second add-on, which is quite a cool one, is the MELFA Smart Plus system. So the Smart Plus system is nice because we have 2 functions with it. We have the intelligent function where we can monitor all of the inputs of the robot, from the torque on the servo joints all the way through to the load on the joints, as well as understanding exactly how hard this robot is working. We have the B type, which is the AI functionality using Mitsubishi's MyZart proprietary AI technology. And it's a compact AI, and what we do with this is we pull a whole bunch of data through this AI algorithm, and we'll be able to actually give you predictive maintenance or warnings based upon failures that could possibly happen in the near future based upon the use of the robot. So there's a lot of data that we collect to be able to anticipate a failure going forward, or what joint or what belt will need replacing, whether it's premature or on its maintenance schedule as well. So yes, the Smart Plus, the focus on the predictive maintenance is very cool. So essentially, as we can see, we've got some images here where we're actually pulling levels of vibration and also the load on the joints and on everything there. And we can tell you, okay, cool, we need to look at changing the belts, or the environment's not correct for the robot, and we'll start warning you, and then from there we'll alert you according to that. And this is all built into this card that's built on. So a lot of information there. For the preventative maintenance as well and the predictive, we have more than just a standard set. So the robot controller and the software, we have a standard set of run hours. How long have the joints been running? How long has the system been on for? We take that information and then we compile it, and we say, okay, cool. Well, the life of this, or the life of the joint, or the life of the belt is getting to a certain level, and then from there we can raise an alarm and a warning to say, listen, we need to do this. The Smart Plus just takes it one step further, and we start doing predictive analysis on this, and we can have a look to the future based upon the load, and also model it as well in our software. So we have a 3D modeling package that's inside of the software, and what we do there is we can actually simulate the entire load environment of the robot to give us an idea of what's going to happen to the joints. Is this robot working too hard? What is the lifespan going to be? And then from there, we just add on to that using this Smart Plus system. Very cool. We can take this, also pull this data out, and we can display it on an HMI, which I'll show you shortly as well. Okay, our robots have a couple of different operating modes. Okay, we have a teaching pendant, whether it be an R56 TB, which is the big one with a color screen, or an R32 TB, which is a small one. These teaching pendants allow us to program the robot in a safe way without it being in a cage. We have a dead man switch basically on these that you have to hold in, and you'll be able to jog the robot via joint positions, or via coordinates on a Cartesian plane. So by doing this, you could essentially program your robot you have your robot set up, you have a pick and place application that you want to do. You can position and move the robot to exactly where it needs to be. And then you can mark that as the set of coordinates or the joint positions that you want to use in your program. And you can also actually do basic programming with the teaching pendant as well. The teaching pendant is also fantastic because we can pull all the error codes. We can see exactly what the life of the joints are, what's going on. So it's quite a nice handy tool for diagnosis as well as for programming as well. So in manual, in automatic mode, the robot with teaching pendant has no inputs. The system runs and it'll run at the designed specified cycle time or speed, etc. When we use the teaching pendant, we switch it to manual mode. It then shuts the speed down and we're limited to about, I think about 250 millimeters a second. And we can go right down to even lower than that, just for safety. We have the dead man switch and of course an emergency stop button on the teaching pendants as well. So it's, if there's any issues, you could just hit that and it would slow down, but or stop completely and make the servos go into an off position, a safe off essentially. So robot control, there's three ways to do it. So in RT Toolbox, which is our software, we can actually control the robot by connecting a laptop through. You'll see there's a little green image there with a whole bunch of buttons and stuff. It basically mimics a teaching pendant. And we can also do control via RT Toolbox or jog and move the robot around for programming. We have IO mode on the teaching pendant as well, which looks exactly the same. So this is one way we can control the robot as well in automatic mode via the teaching pendant. And the last one we have is via Microsoft's ActiveX. So you can actually build a little environment using Visual Basic or C++, where you can actually control the robot if you really wanted to go down that road as well. So it's nice to have a bit of extra ways to be able to control this robot. But the most common ways we do it is essentially we'll use a teaching pendant and then we'll teach the points that we want and then we'll write a program inside of RT Toolbox. We use a language called MELFA Basic, which is not a very difficult language to use. It is almost like structured text, essentially, where we can tell the robot what to do based on coordinates, and you can define certain points as what they are in your program. From there, we have a nice set of mimics for your HMIs as well, that literally just drop them down and then connect your GOT 2000 directly to the robot controller. All the information on the robot is then displayed on your HMI. All these things have been set up. The dressing's already been done. It's a very simple thing. We just tell it what robot we're talking about and off we go. I would just also like to make mention as well that the documentation for Mitsubishi robots is absolutely exceptional. There is a huge array of information on the right-hand side of my screen here. You can see a couple of examples of this. There are documents for absolutely everything on the robot. Yes, they are sophisticated, but the documentation also guides you through the whole process, and you'll be able to find solutions in there throughout all the manuals for all the different types of integrations you want to do. There's also the maintenance manual is also very thorough, which we will touch on shortly as well. Maintenance, okay. Right, so robots are like cars. They will go and they will go and they will go, but if you don't maintain them, they will not go anymore. So if you don't change your oil in your car in a couple of years, you're going to get some problems further down the line. But if you maintain it well, then you're going to get a long life out of it. So our robots have a great lifespan. I mean, you're looking at about 10, 15 years of service out of them if you maintain them properly. I mean, they're really good. And, you know, they're obviously designed specific for application. You don't over rev them, they'll be okay. But this is all part of the solution building. We'll look at that in, you know, before we even deploy a robot. We'll make sure that we're not going over the limits of the robot's joints and weights. So typically on the right-hand side, what I've done here is I've just given a little snapshot from the manual, and our robots require quite a lot of maintenance, but not in a crazy sense. I'll explain why now. So we do a daily inspection generally, make sure that everything's fine. It's a visual inspection, everything's okay, fire it up, off we go. Then we have monthly inspections, 6-month inspections, 2 years, and then battery replacements, which we'll touch on just now, lubrication. So every X amount of hours that the robot runs, we obviously log all that. We will say, listen, we need some maintenance, and we need to go and do exactly what's set in the manual. Fairly simple. Of course, not one size fits all. So robots, if you've got robots that are running 24 hours a day, working pretty hard, they're going to need maintenance way more often than that. So we have a little calculation that we can put together to be able to give you an approximate idea of when your maintenance is required. So for instance, if you're running 2 shifts at 15 hours a day, 20 days a month, 12 months, then every 3,600 hours, we're going to need to be doing some maintenance. And obviously, if it's working less, then less maintenance. So the main parts of maintenance on the robot is the BBG, which is the belts, the batteries, and the grease. So belts need to be replaced about every 35,000 hours of operation. But once again, this also depends on load. We have in our documentation, this show you exactly how to inspect them and what to look for. Batteries once a year. This is an important one, as our batteries basically hold the absolute positions for the encoders and the servos inside the robot. So what will happen is we will send an alarm through saying, listen, the batteries are low, or listen, we need to replace the batteries. If the batteries go flat and the robot loses its power, what will happen is we lose the absolute encoder position. The problem with this is that now the robot doesn't know where it's orientated and what it needs to be. So in the cover of the robot, we do have the absolute positions in there that can be reprogrammed back into the robot, and off we go. Failing that, we'd have to jig the robot and get it to its absolute position. There are some little lines on some of the robots that we can line them up to, but it needs to be, these are very, very accurate pieces of equipment. So we don't really want to get to that stage where we lose batteries. So it's exceptionally important that we recommend once a year battery changes, or as soon as that alarm comes on, follow the battery replace process. Greasing every 6,000 hours. Now, these manuals are so intense that I was reading the other day that on a greasing procedure for certain ball screws on some of the robots, we have to measure out 1 gram of grease. There's a special grease that we have to use, and we have to get a little scale, and we have to measure it out as 1 gram of grease, and that's all we put in there into the joint. So it's quite it's like a very fine-tuned Japanese piece of kit. It really, really requires attention, but that's how we get the accuracy and the reliability out of these. Yeah, so we get a maintenance forecast. You see in the top right of the screen there, you can have a look at the joints and how long it's running for, and a good estimate of when things need to be done. And all this information can be pulled from any robot using the RT Toolbox software. All right, so RT Toolbox. So I've got an example here of what our RT Toolbox software looks like. So we have a 3D modeling, as I've said before. You have your control in the green on the right hand side there, and then your programming, etc. on the left hand side. So we can bring in the bench where the robot's going to be sitting, build a cage around, add your sensors, etc., and do your programming from here and simulate the whole process. While we're doing this, we can also simulate the load I've mentioned just before as well, and we can actually have a look how much this robot is going to, how well it's going to perform in its life. From there, once you've done, you're happy with your simulation, stick it straight on your robot, and just download it straight to your robot, and off you go. It's as easy as that, really. Yes, this is exactly what our software looks like. So some of the applications, I've got this is just a little pick and place example of a program. And on the right hand side, you can see this is the program that we would write in the MELFA Basic to make this happen. It's a little bit technical, but we can look at these kind of solutions going forward. We also offer to be able to go through simulations and have them checked by Mitsubishi Electric as well. And then give us some guidance on maybe there's a better way to do something. There are a lot of functions inside these robots, a lot of very clever functions like palletizing, for instance. It's built in. We just have to add the palletizing into your code, and it knows what to do. It's very, very clever in that sense. And there's many, many different applications that are already predefined that we can sit and fiddle with. So I've got two applications here that I would like to show you. You're not going to see any, not going to hear any audio from them, but I'll just talk you through exactly what's going on. So the first one on the left-hand side. So the first one on the left-hand side is one of our SCARA robots. And this is basically doing a gluing application. So it's an application, this is still in the commissioning phase, this project, but I believe it is running now. This is running a full IQR PLC with a robot CPU controller, got 2000 HMI, and a horizontal SCARA robot that is actually moving the glue head around to put the glue onto the glass here. So this is done in partnership with Autotronics, a system integrator, and this is the machine that they've built using one of our robots. Yeah, so that's that application. And then we are looking at a inspection application as well. So this is our demo robot, RV2. She or he needs a name. I'm still getting there to name this one, but this is the robot that we used on our sand and we use for demo purposes as well. So what we've got here is we've got a Cognex vision system that's sitting on the end of the robot. And what we're doing is we're just taking pictures of certain areas around this radiator grill, and we're comparing it to a set of images that has been preset as, yes, this is fine, and no, this is not fine. All this robot is doing is it's taking photos around the area, and it's giving us a pass-fail. If we pass, we move on. If we fail, we go back. We've got this hooked up to a FX5 PLC. So it's a standalone controller. So there's no IQR robot CPU for the IQR. We hooked it up directly to the FX5 PLC, and we're using a got simple here as well, just to display information, start, stop the process, etc. So this is more proof of concept where we're looking at the moment. And for this specific customer, we would be looking at a MELFA Assister collaborative robot for this application. We essentially, we just take the program out of this one right here and stick it in the new one and just modify a little bit and off we go. So that is something else, that a good example of what we can use these robots for, rather than having sophisticated servo-based systems. This guy will operate like this 24 hours a day. Alrighty, so let's just go to the next one. Okay, I would like to talk a little bit about Assister. So I mentioned before collaborative robots. MELFA Assister is our collaborative robot and is a very nice piece of kit, if I might say so myself. So essentially, this robot, as I've said, is designed to work with humans. And we have partnered with a couple of other companies like Cognex, for instance, for vision systems, and a couple of gripper companies as well. We have bolt-on off-the-shelf solutions to stick straight onto the end of the head of the robot. These robots have like a skin on them as well. They have a lighting system that changes color depending on what mood it's in. No, not really. Depending on how close you're getting or what status it's in. It's red, green, and yellow, I think. And also, these robots are very easy to program. So you wouldn't need a teaching pendant for something like this, because you could actually just move the head of the robot around to give it the points, and then set the points on the control panel on the robot, or using a visual-based programming utility that can be put onto a tablet. So an example here basically is you don't have to be a rocket scientist. You could basically learn how to program and get this thing going with a bit of logic using a tablet, essentially, which makes it nice and easy, very reliable, and with all the standardized equipment that we can stick on that's already pre-programmed, especially with Cognex vision systems. These vision systems, we don't have to do anything funny to integrate with the robot. They integrate very easily to them, and then they'll give us the information that we require. The camera does the work, and we get the data we need, and then we can carry on from there. So this is the type of robot that we would use in that inspection system and environment. And there's nothing that says this robot cannot be used in a full cage environment either, because this robot, like our other robots, is also a full-on industrial robot. You stick him in a cage, and you can do your 1 meter per second high-speed runs. And then when you open the cage, so basically all the safety features you would put on a standard industrial robot, the MELFA Assister comes with a much more simplified, easier package to use on that. So this assistant robot, we think we can only do about 5 kilograms. That's maximum load rating. This is more for, if you're going to do any sort of pharmaceutical-based thing or inspection-based, where you're in close proximity to people. And also you can put it in a cage as well and go all the way. So it's not as accurate as the other robots. It's 0.03 millimeters repeatability, but it's still very, very accurate. And it can also operate in a range of quite many ranges of environments as well. So that's the assister. And we're hoping to get 1 or 2 of those up and running in South Africa very soon. There are many applications that we're looking at, and a robot can really help solve all your needs. It's the initial investment is really worth it in the long run. If you think about robots can just work 24 hours a day, and if maintained correctly are very, very reliable. If you have any questions, please feel free to post them in the chat and we can talk about them. Otherwise, you may email me and we can have a bit more of a technical discussion around these robots and see if we can put a solution together for you. Thank you very much.